The topic of today's presentation is the research project that Lee and Daffner, Chris McGlinchey, and I are carrying out at MOMA since last June 2015. And I'm pleased to be here, but I represent all of them. So rather than taking pictures or write a lot of notes, please take a picture now of this QR code. This is not a hinge or an adhesive. This is a code, and if you can scan it or take note of this link, you can find this presentation online or part of it. I will present some of our findings, and some of them will not be understandable online when this video of these 2 days symposium will be online. So this is another way to review our findings, and for us, it's also a tool that will help us to receive your comments, suggestions for adhesives, or if you have experienced other solution for hinging RC papers. All of these information will be more than welcome. The Museum of Modern Art maintains a very active exhibition program for 3 million visitors per year through an average of 50 on-site presentations, 10 to 10 traveling partnership exhibition and projects. With one gallery of 1,500 square feet devoted exclusively to photography, there are photographs to be found in every curatorial department and are integrated into a number of exhibitions across the board. The acquisition and display of resin-coated photographs and digital prints on RC-type papers is now routine. Some of the oversized print can be quite large. These works, as well as many contemporary photographs, require delicate, minimal exhibition mounting, but present certain challenges. Conservators hinge RC papers relying on available adhesives, on their experience, and by following colleagues' recommendations. The photograph and science section of the conservation department is currently investigating a selection of adhesives and attachment systems for the display of resin-coated photographs. Here you see an overview of the studies on adhesives for RC papers to date. In 2004, MOMA investigated new adhesive formulations for polyolefin surfaces. And building on that research, this study is aimed at evaluating products now currently available and in use for conservators. We are approaching this investigation from 2 angles. On your left, the first is an assessment and how a selection of adhesives on 2 carriers performs on one RC paper. The second, on your right, considers the materials attributes of classic RC papers to ones that are currently available. We purchased a variety of adhesive, of course, tapes and adhesive films potentially suitable for hinging RC papers. Our selection criteria was directed by our knowledge, our familiarity with the adhesives, by available testing results such as BAT and Audi tests, but also by collegial recommendations and literature research. Admittedly, the curiosity for unusual adhesives also played a role in our selection. We conducted a number of preliminary evaluations to eliminate hinge combinations that appear fundamentally flawed. In these pre-tests, products were scored according to shear strength and removability. Shear was scored on a pass-fail basis, and removability was ranked numerically. If a hinge was easy to remove, it was assigned a higher score. If it caused planar deformations, left residues, or caused skinning or burnishing, it was given a lower score. This image here shows you our heavyweight test, where a hinge with a contact area of 0.5 square centimeter and a load of 270 grams gives the approximation of the shock a photograph in a crate in transit might receive if the crate suddenly drops. Originally, 2% gelatin failed this test, but we repeat this test with gelatin 5% on Holitex, and the hinge remained suspending, and this was quite impressive to us. Adhesives that did not make this cut are listed here on your left. There are the ones that didn't pass the shear test. But on your right, you have the results for the removability test. So 14 of the original 50 combination of adhesives and carrier failed in the pretest. It's about 28% of the total 50. Here are, at the end, all the candidates that made it, and they passed the next level, including 10 proprietary adhesives and 9 films and tapes, which form now the core set of materials in this study. They are all commercially available, and if you cannot find your favorite here, please tell us, and we can probably include them in our further testing. We tested then 25 adhesives and tapes applied in a variety of methods. When possible, we applied 2 different carriers, Japanese paper and Holitex, for a total of 50, again, combinations of adhesive and tapes. The contact area for each is, again, 0.5 square centimeter. Each combination was tested in shearing and peeling test. Shear and peel strengths are respectively involved in flat, heavy hinges. Each card tacked to the wall supports 4 RC paper samples with weighted hinges. The 4 duplicates permit us to average results and measure standard deviation. We calculated weight based on weight per area each hinge would support for most photographic prints. We selected a 20-gram weight, which is slightly more than heavyweight paper. So this is our top row, and this is the shear test. In the first month, 7 hinges for 2 different adhesives failed out of a total of 144 samples. And these are Goody Dots and Lascaux 303. But after 7 months, and this picture was taken like a week ago, most adhesives appear strong enough for use as flat hinges. So that means that all of these combinations of adhesives with their carrier, that they could be like paper or Holitex, are actually strong enough to hold that weight. The Lascaux 303 on paper remains adhered to the flat hinge, but the Lascaux 303 on Holitex have all failed. We repeated this test 3 times to confirm the findings, and always we had the same result. This underscores the importance of the bonding system and the carrier of the hinge, which plays definitely a critical role. Goody Dot samples on both paper and Holitex carrier failed the test. For those of you who are not familiar with Goody Dots, this is an adhesive that passed the PAT, and it's essentially applied to substrate in microdot pattern. If a small portion of this hinge fails, the remaining hinges would have to bear twice the load, causing failure due to overloading. This product can eventually be perfect, however, for little weight papers. Okay, it works. In peel test, however, there was much more action, likely. We documented the cards at all stages. The scale bar on each sample allows us to monitor and quantify the creep. And this is the little scale that we apply to each sample. So we can track actually how each sample creep during this test. In this video, we are going to scroll through the status of the peel test as of last week. This is after only 4 of the 9 months experiments. The peanut boards contains again 4 samples with identical carrier, Japanese paper or Holitex, and of course for tapes, this does not always apply. Red colorized fields are outright failures, yellow are borderline or questionable system, and light green are so far looking good, but the brightest green are so far the ones that didn't show any creep at all. Instances where two different colors appear simultaneously are instances where the carrier is having some influence on the bond strength. During installation and by the end of the first week, a number of samples failed completely. We repeated this to verify that the application didn't affect the integrity of the bond. This was even repeated with lighter weights, and we found they failed too. We will provide an update after testing is completed in 5 months. And with this video, we want to show that there is a role that paper carrier influences the adhesives bond. Let me remind you that we conducted all of these tests using just one type of RC paper. And you will find in the presentation online the results listed, so you don't kind of get crazy looking at the images stopping the video. Now, the last part of this talk is going to focus on characterizing RC paper in photography and now digital printing. We initially selected 13 papers. These include vintage and currently available RC paper and RC type papers. We decided to include the digital papers because these materials are acquired by and displayed at MOMA and come into the lab on a regular basis. If the previous finding suggests the adhesive carrier interaction influences the bond, the next part of this study examines papers and how their inherent properties might influence adhesion. Our collection is growing and we are getting additional paper, both new and vintage. The resin in RC paper is polyethylene. This polymer is a polyolefin which is characterized by a long aliphatic non-polar chain structure consisting in only carbon-carbon and carbon-hydrogen bonds. The image on the right shows a 100 microliter drop of water on polyethylene, a material that water has a very little affinity for. This is the crux of the problem for RC prints in general. Adhesives that have a very good cohesive strength arising from their own polarity have a weak affinity for non-polar material like polyethylene. Wetting is the first step towards adhesion. Consider the long-term ramification of a bond between two materials that have a weak affinity for each other. If the substrate was more polar, however, like polyester or even an unoxidized polyethylene, the water would more effectively wet the surface. We can quantify the difference with contact angle measurements, which we will show in a few slides. We did ATR, FTIR on our RC paper samples, and by inspecting the carbonyl region, we can see that not all RC papers are pure unoxidized polyolefins. The FTIR of these 13 papers suggests only a few are pure polyethylene, while some must contain components or oxidized polyethylene due to the presence of carbonyl, or carbon double bonded to oxygen. It is interesting to know that the two bottom spectra here that don't indicate any carbonyl are associated with the vintage papers. So the oxidation is not age-related. Rather, manufacturers later learned that some polarity would improve inks and markers to stick to the verso. Obviously, this opens up our option for adhesives too. In this detail of the previous spectra, we see only the carbonyl absorption band. The samples colored out on the right have a carbonyl maximum at about 1720. This is an excellent agreement with the literature for polyethylene that has been oxidized by corona discharge. We also find in the patent literature for photographic papers corona discharge being the method used to improve the paper's compatibility with inks. Traditional adhesives might be viable for these polar RC papers. Not every conservator, then, has FTIR to identify the papers, but the contact angle test might suffice in assessing the paper's surface polarity and therefore potential adhesive suitable for use. In this test, we used a small mechanic mirror set at 45-degree angle with a few microscope slides to raise the paper so it could easily be viewed in the reflected image with a microscope. The paper being tested was weighted down and a 100 microliter drop was placed on the paper. We waited for 3 seconds and captured the image. And you can see here with this video how that happened, and it was so beautiful, I guess. We wanted for the droplet it's almost invisible at naked eye and theoretically non-destructive. You will find technical information about the mirror and the special pipette we used at the end of this presentation or also online. The angle of contact in the image was measured in Photoshop. And that was great because you can actually have the right angle that you can just using that software. And you can see here that not all RC papers have the same polarity. These are our results. Oh, sorry. Previously, we inferred that RC prints were non-polar, but this is only true for some papers, not for all. Early RC prints were non-polar, but today this is much less likely to be the case. The image at the left concurs with the image at the left concurs with the FTIR spectra. These systems are the most aliphatic or hydrophobic, and the ones on the right have the strongest carbonyl signal. The ILFO multigrade, which is this in yellow, is the paper we are using in our original adhesive testing because this is a true polyolefin, meaning it is hydrophobic and relatively difficult to get adhesive to stay stuck together. We are conducting surface characterization studies on all these paper samples to evaluate if and how surface roughness influences adhesion. So in here, our light section, and this is actually the surface, of course, of the verso. The differential interference contrast, micro-raking imaging, and micro-raking imaging with enhanced contrast, and we using the workflow that Paul Messier used for the Thomas Walter project. So there are a number of next steps in the queue for us in the next months, including artificial aging, research, hinge removal assessment, and testing to evaluate the chemical stability of the image material with the adhesives. But suggestions for additional adhesives and carrier are more than welcome for further testing. Please send us your ideas. And I'd like to thank again Jay and Sarah, FASC, and Center for Creative Photography. Thank you.